This question asks us to determine the enthalpy of reaction for the reaction of carbon with hydrogen gas to make methane. You might recognize that this is actually the formation reaction of methane, so what we're actually looking for is the enthalpy of formation for methane. If we look at the three reactions that we've been given, this first one is the opposite, so the reverse of a formation reaction. The second one is a formation reaction as it's written, but the third reaction is not a formation reaction if it's written as it is or if it's flipped. So we can't use the formula because you can only use the formula if all of the enthalpies you're working with are enthalpies of formation. So let's start by finding an alternate route then to our overall reaction that we're interested in. Looking at this first reaction, we have carbon as solid graphite on the right as a product, but in our overall reaction we want to have it as a reactant, so I'm going to flip this reaction. Because I've flipped the reaction, I'm also going to flip the sign of the enthalpy change. For the second reaction, we have hydrogen gas on the left as a reactant, which is exactly where we wanted it in our overall reaction, so I'm going to keep this reaction as is. For our third reaction, we have methane on the right as a product, which is exactly where we want it in our overall reaction. So I'm also going to keep this reaction as is. Now, in the overall reaction, we want to have 2 moles of H2 gas, so I'm going to multiply our second reaction by 2. In doing this, I also need to multiply the enthalpy by 2. Okay, so now I'm going to add up the reactions and see if it cancels out to the correct overall reaction. So on the left we have carbon as solid graphite. Next I have an O2 gas, which will cancel out with one of the O2 gases in the products on the right, and the other one will cancel out from here, so there's no net oxygen. The next reactant I have is these 2 hydrogens. And then the carbon dioxide down here will cancel with the carbon dioxide in the products, and the water will cancel with the water. So overall I have carbon, solid graphite, plus 2 moles of H2 gas going to methane gas, which is exactly the overall reaction we want. Thus, we just need to add up these enthalpies and we will get the enthalpy of reaction, which happens to be the enthalpy of formation for methane that we're looking for. So if we add those up, we find that delta H of reaction is equal to negative 74.79 kilojoules per mole. Now there's a second way that you could have solved this problem, so I'm going to show you that way now. So here's a second way to go about finding the solution. If you notice that the first reaction is just the reverse of a formation reaction, and that the second reaction is a formation reaction as written, that the reaction that we're looking for overall is a formation reaction, then this third reaction here, you might have recognized that we can use the formula for this reaction to solve for the enthalpy of formation for methane, which is exactly what we're looking for at the top here. So our delta H of reaction for the third reaction is equal to 890.36 kilojoules per mole. That is equal to the enthalpy of formation of the products minus the enthalpy of formation for the reactants. So our first product here is CH4 plus 2 times the enthalpy of O2 gas. Now we need to subtract the enthalpies of formation of the reactants. So carbon dioxide, so delta H formation of carbon dioxide as a gas, and we also need to subtract 2 times the enthalpy of formation for water. Okay, so the enthalpy of formation of methane is what we're looking for, so we don't know anything about that yet. We know that since oxygen as O2 and a gas is its standard state, we know this enthalpy of formation will be 0, so that will go away. As far as the enthalpy of formation of CO2 goes, that is exactly this enthalpy here, except with the opposite sign, so negative 393.51, since if we flip this reaction, it will be the formation reaction for carbon dioxide. So we can write this out then as delta H formation of CH4 minus the delta H formation for CO2, which is negative 393.51. And now we have 2 times the enthalpy of formation of water, which is just this as written here, so negative 285.82 kilojoules per mole. If I rearrange this equation and solve for the enthalpy of formation of CH4, then you will find that the enthalpy of formation is equal to negative 74.79 kilojoules per mole, just as we did when we solved it using the first method.